Hello and welcome to the Embedded Frontier podcast. I'm your host, Jacob Beningo, and today we are going to be talking about trends in the embedded software industry. That's right, you can't think about the embedded frontier without getting into trends. And with this being the start of a new year, it's the perfect time for us to stop, reflect a little bit about where the industry's at, where it's going, and of course, figure out where we fit within the larger industry and determine what practices we need to adopt in order to stay relevant and current in the new year. Now, as the year comes to a close and a new year begins, you may find yourself reviewing what went well and what didn't. This is very common for us to do as humans, I guess you could say. Yearly reflection can help you and your development team fine tune your direction so that you can have a successful year. Now, as I mentioned, an excellent exercise to perform is to actually look at where the embedded software industry is going, what trends will affect you, which ones are going to affect your customers, and to try to figure out what adaptations and adjustments you need to make this year in order to be successful. Now, the embedded software industry can range quite a bit, right? This is a huge industry. We have some companies that are running little 8-bit microcontrollers that are very resource constrained, others that are running complex systems that have multiple cores, are running FPGAs, application processors, all kinds of things. The embedded system industry is a wide variety of devices and techniques that can be applied. And so while our industry is quite vast, what we're going to do is we're going to focus in a little bit on what we think, or that I think you should be watching in 2024 and beyond within the microcontroller space. Okay. And we'll look a little bit at real-time systems in today's session. But again, we're going to talk about what I think maybe the top 5 trends are that we should be looking at. And then before the end of this session, I'm also going to share some practices that I think will help you to be more successful this year in developing embedded software. And so we'll talk about those towards the end. First, we need to understand where we're at and where we are going. Now, the first trend for us to discuss today is going to be, wait for it, ready? It's what everyone is thinking. It is, of course, how we can leverage AI to develop embedded systems. Now, just a couple of years ago, we weren't really talking much about artificial intelligence in the embedded system space. Sure, if you were running high-end processors, it was something that we talked about. We talked a little bit about, using AI in the cloud, maybe taking images and pushing that data up to the cloud and waiting for a response to get back to the edge. Well, we never really thought much about trying to develop software using AI. Of course, all of that changed late last year. In 2022, when ChatGPT came out, along with a number of other large language models that are easily accessible to developers today. And that kind of created a ballooning of AI technologies that are available for developers to use. And for us embedded software developers, there's several different areas where I think you will find that artificial intelligence really starts to find its way into our development lifecycle, okay? And these start out kind of innocuously, right? You could look at some of these technologies and tools that are available for code generation, right? You could use tools like, BART or ChatGPT to help develop code for you and auto-generate it. Those are great tools that you can use. I've had relatively good success actually generating some code. Sometimes it's painful to figure out the right prompts, but once you figure it out, it can generate relatively decent code for you. Alternative tools that you can think of, Copilot, right? From GitHub is a fantastic tool. Again, right now, today, currently, I've been finding that it's a tool that is getting you maybe, when I develop software, maybe 50%, 25 to 50% of the time, it's giving me good suggestions for code to, that it's going to generate for me. And so, that's 25 to 50% of something that is going to help me speed up my development of my code, right? And so some of these technologies, they are very new. And as I mentioned, 25 to 50%, that means that they're not something that you're just going to say, hey, go build me this algorithm and the artificial intelligence is going to, give you the result, right? This is really, it's not something that's going to take over your job in the near future. It's a tool that you're going to be able to leverage in order to really improve your efficiency, your throughput, develop more reliable code, and do so in a way that's going to allow you to get there kind of faster, okay? And so when you think about code generation, in the past, code generation tools have always been absolutely horrendous, right? If you look at some of the tools that generate things from like model-based designs, a human can't even read the code. The interesting thing with AI tools is that they can generate code that is human readable. We can actually train these models based on how we want to develop software using our own coding styles, coding standards, and our own best practices, right? And so this is an area where I think we're going to see a lot of development this year is in automatic code generation of higher reliability software, right? A lot of these tools today are being built and are trained off of open source software. And I don't want to knock open source software because it is fantastic. It plays a great role in our industry. But at the same time, it may or may not be of high quality, right? There's a lot of people who are putting their code bases out there, being very nice, but it's not necessarily software that's designed for higher reliability applications. And so what I think we'll see is an increase in the reliability of some of the software that's generated by these artificial intelligence models. I think as an embedded developer, you will also start to see your team start to really leverage it to help you debug your systems. I've been doing lots of experiments with some of my customers and even myself when I develop software. When I run into problems, if something's not obvious, or even if it is obvious, uh, throwing it into a large language model and seeing what kind of solutions it comes up with. Is it pointing me in the right direction? Is it taking me down some circular path? And again, to get good results, it really depends on how you ask these questions, what information you give the models. But I have found that when you're trying to debug a system, maybe it's a simple script or whatever it might be, these tools can help you see some potential issues or find things a little bit faster. Okay, especially if it's in if you're using a new language, maybe that you're not familiar with, maybe you're using Rust, maybe you're using C++ and you're normally a C programmer or something like that. I have found that you can gain insights and use AI as a learning tool. Although again, you have to be careful. You can't always trust what it's providing you. If you take it with a grain of salt, but then kind of analyze that, I think what you'll find is that again, using AI for debugging is actually a pretty cool thing, and it will help you, I think, in this year get to your spend less time debugging. What you will find is that there's actually something along the lines of like 40 to 80% of a developer's time is spent debugging their software. Okay, that's huge. That is a lot of time. Okay, we really should be striving to be at like 20% or less. I know when I first started developing embedded software, I was one of those people who was up around that 80% mark. Not really where you want to be. But as I learned new debugging techniques, really, became better at how I designed, tested, implemented, and debugged. I now spend probably less than 10%. But there's always going to be some debugging, and you want to leverage all the tools you can. And artificial intelligence is one of those tools that I think you'll find is very helpful in helping you identify what some of the issues are that maybe you're facing. It can help you get there at the end of the day a little bit faster. I've also found another area that's artificial intelligence can be used in that's quite interesting is for code reviews. I find a lot of teams struggle with reviewing their software. Okay, yes, we have Git, and we can with our merge requests we can kind of gate those merge requests for people to go in and review and approve software. And I do see a lot of teams taking advantage of those types of techniques, which is fantastic. But at the same time, I see a lot of teams that are still skipping code reviews. And code reviews are the best way to actually identify those bugs early in the development cycle before they get kind of pushed out to production and become very costly. Even if they're caught before you go to production, but at the end of your development lifecycle, they're still exponentially more expensive to fix, to find and fix than they are early on in your development cycle. And so leveraging AI tools to be able to do code reviews to tell you maybe where code could be improved, where it can be made more efficient. Those are the types of things that you want to be looking for as the year progresses and you're starting to find new techniques that you're trying to implement in your own development life cycles. Okay, and so code reviews are a great area. I can give you an example here of a project that I was recently working on where I actually leveraged a little bit of code generation and code review. I had some code that I was working on from a customer, was reviewing it. I looked at it. They were having issues with their system. It wasn't performing very well. And I was able to kind of identify, okay, this is the function that's really causing 80% of the problems here. And as I look through how it was designed, it's like, okay, well, this function it's not designed very well. It's developed by maybe some entry level engineers or something. And I said, okay, I need to go back. I need to rewrite this the right way. There were way too many register rights and just some things about the way it was architected that was just inefficient. And then I was looking at it and I said, well, I can go through and I can write this myself. But let me see what kind of suggestions maybe that an AI tool has on how to rewrite this, right? I know how to do it, but let's see what it comes up with. The AI tool gave the exact same, not the exact same analysis, but came to similar conclusions that I did. And then I said, well, hey, generate a new function that's more efficient that does the same thing, okay? And in about 15 seconds, I had this function that was written that I could use to replace the one that was there before, that we were able to test and debug and verify, yep, this works. This is great. Okay. And so the moral of the story there is, well, I could have developed the function myself. I identified the problem, verified it myself, then verified it with a tool, and then used the tool to generate new code. I verified then that what it generated made sense. Of course, made some tweaks and adjustments myself, and then basically got the system working much more efficiently. And instead of this taking a very long time, this is something that maybe it was actually a pretty big problem, but we, in a matter of maybe 30 minutes, it was resolved. Okay, 30 minutes to 60 minutes. And so again, leveraging AI in this way, it might take me an hour to hand code it myself and go through all the testing procedures, but instead, 30 minutes between code generation, identification, verification, all that stuff. Which again, in an age where we are expected to do so much in our development cycle and systems are becoming so complex, leveraging any tool that can help you go faster is going to be a good one. Okay. And don't get me wrong, I'm giving you the examples of where these things went right. I have plenty of examples of where things went wrong, where I asked for something, to be generated or reviewed something, and I was like, oh my gosh, this AI is way off in the weeds. It has no clue what is going on. And myself, with a minute of reviewing, was like, okay, yeah, here's the problem, right? Where the AI would have taken me on a hour long, circular path where maybe I never would have actually found what the problem was. So with that, little caveat warning there, leveraging AI tools in your development lifecycle is going to become more common this year. It's a potentially great and game-changing tool for you to use. But again, be careful of how you leverage those technologies. Now, another trend that I think we're going to see over the course of this year, and this is a trend that's been going on for several years now, but embedded software developers have been slightly ignoring it, at least in the smaller to medium-sized companies, and that's improving their CI/CD processes. Okay, I still see a lot of teams that don't necessarily leverage CI/CD, maybe aren't using Jenkins or GitHub or GitLab to really create a nice automated development lifecycle process that allows them to integrate their code continuously and deploy that to the field. Now, of course, these types of things all kind of come back to these ideas of DevOps processes, which goes far beyond just CI/CD pipelines, right? CI/CD is really kind of a tool that we can leverage in order to automate our systems. And so we want to be able to automate the building of our software. We want to be able to perform automated analyses, things like static analysis, verifying that code is actually meeting our coding standards, maybe checks against things like MISRA-C, generating metrics, all of those types of things. We want those things to happen, right? But we don't necessarily want to have to be doing those ourselves manually over and over and over again. Instead, we can rely on these automation tools to help us get there. And these tools have evolved at a rapid pace. They are fantastic. Depending on the size of your team, some people say, oh my gosh, these tools are expensive. But at the same time, when you look at the value that they provide to you in the development lifecycle, they're actually quite cheap. They provide a lot of return on investment for you. And so, again, I think we're going to be seeing a lot of improvements in CI/CD. I know for embedded software developers, the CD part of that, continuous deployment, is something that we often struggle with, okay? Because if I'm going to be launching firmware into the field, I don't necessarily for every product need to be continuously pushing firmware out there. If I have a internet connected microwave, that microwave probably doesn't need feature updates every day, every time I push new firmware, right? But maybe I do have a quarterly release or yearly release of firmware updates for bugs or security vulnerabilities and things like that, right? As soon as you connect a device, there's going to be vulnerabilities that you have to be concerned with. And so while we might not be continuously deploying daily, we may still have a monthly or quarterly cadence. But even with that in mind, you may actually have a daily deployment to some hardware testing environment. And so deployment to some type of production development environment or production staging environment where quality assurance teams can play with the code, verify that things are actually working the way that you expect them to, even though they've passed the pipelines. That doesn't mean that everything is working as expected per the requirements, right? There could still be issues and things like that in there. So, but again, as we start to mature CI/CD processes, I think you're going to see a lot of benefit there. I am starting to see more teams wanting to actually, instead of just having the CI piece and maybe some CD, I'm actually starting to see an increased interest in having hardware-based testing. Okay, so I see a lot of teams that will, they'll build their code, they'll analyze it, and they'll say, okay, cool, and then they'll really take manual process. They'll take a manual process offline in order to do manual tests at a system level. Okay, but I'm seeing a lot of people start to really say, okay, we're at that stage now that system level testing that's automated is on the table, right? And so those are some things that you might want to be looking at. They can be more complex, but at the same time, most companies that I work with, what we're doing is we're building out Python scripts that allow us to do system level testing. We review telemetry and maybe have IO and different sensors connected to the system that we're working on and trying to verify. And then we're using scripts to kind of collect all of that data and then go through some type of automated process to verify that, yes, the system is actually responding the way we expect it to in the timeframes that we're expecting. And again, these aren't necessarily trivial things, but CI/CD processes have finally started to move into the embedded space enough that we are finding that is an area where you can look in a little bit more detail and find some pretty good examples out there as well. So, and if that's something that you're like, oh man, I want to learn more about, CI/CD and how to do those types of things, you can always go to beningo.com. I actually teach a course on continuous integration and continuous deployment, which is, it's maybe like a day and a half on demand course. So it's a fun one. You start out developing your own build systems in Make and CMake and using Ninja. And then you actually end up at the end of the day with a full CI/CD pipeline where you actually deploy to a development board actually right there at your own facility connected to your computer. So there's nothing like being able to deploy software and seeing those blinky LEDs turn on at the end of a pipeline. It's quite rewarding. But in any event, I digress here a little bit. Let's get back to talking about some of these trends that I think we will be seeing this year and even into the future, right? Trends never change unnecessarily on a year-to-year basis or quarter-to-quarter. Usually there's trends that in our industry tend to be longer reaching. And so the things we're talking about today will still be trends probably next year as well. They just might not be the hottest trend that everybody's focused on, right? And so that's something to keep in mind. For example, a perfect lead into that as an example trend is what I think is the phasing out of C for C++ or possibly Rust in 32-bit applications. Now, I know this has been talked about probably for the last 30 years. When when I was an undergrad 20 years ago, there was within the industry, there was all this talk of how C++ was going to replace C. And here we are 20 years later, and it still hasn't happened. And to be completely honest, you are going to find that C will probably never be phased out of embedded systems. We can probably look 50 years into the future. The C programming language will be 100 years old, and there will still be embedded developers that are using it. Okay, C is a great tool for us. And so you don't necessarily have to be scared that, oh my gosh, I need to learn all these other languages because, C is going away. That's not what is happening. But what is happening is that we have in the 32-bit microcontroller space, the hardware has advanced to a level where it does make a lot of sense to leverage a more modern language to develop your systems. And the languages that are really available for us in the embedded space are C++ and Rust. Now, Rust is still new. It's got a lot of interest. There's a lot of fans out there trying to help promote it and push it. It does have some great things about it. It also has some detriments to it as well. Okay. Whereas, you look at C++, C++ has kind of evolved out of C. It's not C, right? But it has a lot of the features that we can find in Rust as well. There's certainly arguments that people can have as to which one is more efficient and secure and all that kind of stuff, depending on how you're developing your software. But C++ does tend to be perhaps a more natural direction for a lot of C applications, right? It's pretty natural to take your C code. You can easily compile it with a C++ compiler and then write other C++ code, okay? We actually do that in some of my C++ classes where we actually start with an STM32 board we got all the low-level drivers generated by the STM32 Cube IDE, and then we actually hook that into a high-level application code that's written in C++, okay? And so this type of thing is becoming a lot more common. There's lots of teams out there who are just right at the beginning of their project saying, nope, we're going to use C++. Most developers know C++ today. Whereas, 20 years ago, yeah, we were taught C++, but, C++ 20 years ago was very different, right? It wasn't modern C++. It was, kind of an older version of C++. But today, most developers know C++. They're fairly efficient at it. We still have to be very careful with that. Now, you might be saying, okay, yes, I'm talking about C++ here a lot. Rust is that other alternative. I have not seen a lot of companies to date adopt Rust, okay? Lots of companies I see are doing C++. Rust is still new enough. And when you are a company and you're trying to run a business and you're trying to make sure that you minimize your risks, you're generally not going to jump right onto the latest and greatest and hottest looking thing, that you might get stuck with 10 years from now, right? Lots of people are developing platform-based tools or software, right? And what I mean by that is that they're developing code today that they plan on using a decade from now for other products. that they're going to develop. And so they're developing a core platform with common code that's frameworked together to be able to launch off multiple products over a long period of time. If you're going to do that, you have to use a language that you know is going to be around and popular in 10 years. Many of us hope that, Rust fits that bill, but it's still new enough and hasn't been adopted high enough into the industry that it is a little bit risky, right? And you don't necessarily want to adopt something and then 3 years from now, 4 years from now, have to go back and rewrite everything or be struggling because the language is not moving at a rate that you need it to in order to stay modern and up to date. And so I'm not saying that's, that Rust isn't going to be popular in a few years. I see a lot of companies showing a lot of interest in it and learning and starting to kind of gain the tools that they need in order to be proficient at it. And so I do think we will see Rust in that. But at the same time, I think we may be stuck with 3 languages for a while, right? As C kind of disappears a little bit more and a little bit more and a little bit more and phase out over the next decade or two. We will see, I think, the battle switch from C to C++ to C++ and Rust. Okay. And so no matter which language you're using, C, C++, or Rust, your job's going to be safe for a while, at least until the artificial intelligence just generates all the code for us, at which point we'll need to understand how to do model-based development and maybe product-based engineering a little bit better. But even then, at the end of the day, AI tools aren't going to be able to do everything for us. You're always going to require a human in the mix to make sure that things are working, I think, the way that you expect them to. Okay. All right. So another area or trend that I think that we're going to see here over the next several years is and this is a trend that these trends have already kind of been in process for several years, but I think what's happening is we're going to see a renewed focus on these things this year. And this next trend is actually developer-centric workflows. And what I mean by that is that a lot of times what has happened at companies is that companies develop what is their process of the tools you're going to use, the setups, the IDEs, and then they kind of go and they say, when they hire people, they say, everybody's going to adhere to doing things this way across the entire board. Okay. And while that has worked to some degree, it hasn't allowed developers kind of the flexibility to do things fast the way that they know how to do them, right? And what ends up happening is that you end up with struggles within teams because you get a couple of developers and they're like, well, I really like to do things, like A, but you guys are doing them like B. And now I'm trying to convince people that are doing things like B that A is really the right way to do things, right? And so what's happening, I think, and you can see this with Visual Studio Code, is that the adoption of tools that are very configurable allow us to really customize the developer workflow and make it developer-centric rather than company-centric. Okay, and what that means is I can grab Visual Studio Code and I can completely configure it for the way that I want to work in it. Okay, keystrokes, the plugins I use, I can set up my workflow however I want to do it. If I want to use visual looking things, I can do that. If I want to work in a terminal, I can do that. And so what's happening is that we are starting to move to a point where these tools are so configurable that companies don't necessarily have to force you into a specific way of doing things, but that you can say, hey, I work more efficiently like this, and you can customize your tools to work like that. While the developer sitting next to you, your colleague, he can configure tools completely different from you, but still be efficient on his side. And then the guy, just 2 cubicles over from there, or on the other side of the world, with all of us working remotely, configures it again totally differently. But each developer is still able to contribute to the code base. They're able to work in a way that makes them the most efficient. And so I think this developer-centric workflow is, kind of an idea with the tools and the processes we're putting in place that really allow teams to be fast, efficient, and really allow the developers to do what they do best without adding a whole bunch of overhead and frustration to them getting the job done. All right. And so I think we'll be seeing a lot more of that here coming up. One other trend that I also see will be coming up this year, and has been for decades, but particularly in the embedded software industry, this is an area that has really taken off, and that's really moving to higher levels of abstraction. Embedded software developers have always really worked at the low levels. A lot of times it's hardware developers who have started to learn how to develop software, and that's kind of how things worked, right? You had hardware engineers who understood the hardware, and they could write then the embedded software. But so many systems today are IoT connected. They're complex. They've got TCP/IP stacks. If you look at some of these 32-bit microcontrollers, these things are more powerful than the first PCs I used, okay, which were running at like 200 megahertz. So there's microcontrollers that I've seen that are running at a gigahertz that have multiple cores that you could almost run Linux on them if you had an MMU on it. Okay, I mean, these things are getting to a point where they are very complex pieces of hardware. They're very inexpensive. They have got lots of memory. They have that real-time component still. They're all fully integrated, so they are microcontrollers. But at the same time, you can't, an embedded developer isn't going to be able to live at a low level of abstraction. And so I'm seeing this big trend of moving to higher levels of abstraction, very much focused on the application code. We saw from COVID when microcontrollers became difficult to find, right? Lots of people were having a hard time getting the hardware so that they could actually go to production. And so these ideas of hardware abstraction layers, having in, middleware abstractions, using OSLs and things like that, these have all been trends that are helping push this move to higher levels of abstraction, okay? Even the no-code movement of looking at kind of even model-based designs and things like that, where we're really working at a high level, focused on the system. These are all trends that are going to continue, and they're going to become even more prevalent and important in the embedded software industry, especially folks working in microcontrollers and low-level firmware, okay? Now, kind of thinking about those abstractions, this actually brings us to an interesting trend within real-time operating systems, okay? I mentioned a little bit earlier about OSLs, OS abstraction layers. These are still very popular amongst developers. Some developers hate them. Some developers love them, right? Not all RTOSs are not created equally. They're all different. And so trying to make an RTOS kind of fit within that box of an OSL can sometimes be very difficult. But an interesting trend that I have been seeing is the adoption of POSIX APIs, okay? And so rather than working at the RTOS's, I'll call it OSL level, or even directly calling the RTOS's APIs, people are leveraging POSIX APIs, and that provides them, again, a high level of abstraction, but it allows them to adopt kind of more modern development cycle techniques where they can develop their application code to be completely hardware independent. They could run it with free RTOS. They could run it with PX5. They could run it with Zephyr, NutX, pick your favorite RTOS. But these allow them to work in these different areas and keep their application code completely decoupled from that hardware. At the same time, it also allows them then to take that application code, and maybe today they're running on a microcontroller, but maybe in the future they want to build a system that runs on Linux, okay? And so instead of having to go back and rewrite all of their application code, they can seamlessly work in the microcontroller application processor or beyond space, right? And so that gives them a lot of flexibility and a lot of power in how they develop their applications. Now, again, if you're looking at resource-constrained devices, moving to POSIX-based APIs may have a lot of overhead for you. It might not make a lot of sense, okay? But again, the industry is large, and these are some of the trends that I'm seeing, particularly in the 32-bit microcontroller space, okay? And we'll probably continue to see these as the years progress. But again, really exciting, and I think quite interesting for us as developers. I mean, the rate at which things are changing and adapting it's just so exciting. There's so much to do, right? So much to learn. And unfortunately, there's just no way to learn it all. But that's okay. Now, I know we've been talking here for a little bit. I do want to leave you, before we close out here, with a few ideas of techniques and practices that you might actually want to adopt this year as you start to think about where I should be going, okay? Now, just like anything, when you are reviewing things, my recommendation is that you don't make resolutions, but you create new habits, okay? And so if you find that there's some new technique or some trend that you kind of want to jump on board with and you really want to integrate it into your development cycle, make sure you go to your calendar and actually carve out space to make a recurring habit of implementing whatever that technology is, okay? Just saying you want to do something that isn't going to get you there. Yes, you can set goals, but the best thing to do is actually set some type of habit that's either daily, weekly, or something like that will help you start to move towards that goal and actually get you there, okay? Something like 95% of New Year's resolutions fail, and it's because it's nothing more than people saying, oh, I'm going to do this, right? They don't actually put a habit in place to make sure that they can achieve that goal. And that's whether it's a personal goal that you're trying to achieve or a business goal and objective within your team or your company, okay? And so keep that in mind. You want to definitely, when you're going to adopt these things, add some extra meat to it to make sure that you are successful and are able to follow through with these, okay? Now, the first one, which I've kind of alluded to a little bit before, and this is a practice or a technique that I think a lot of teams could benefit from, and that's the use of model-based design. Okay. Traditionally, we've always worked as embedded software developers at the lowest level. We look at the hardware and we work our way up to the top of the development stack of our software stack. Well, that's changing. If we want to be hardware independent and we want our applications to be portable, scalable, and reusable and leverage modern techniques, we actually have to think from the top down. And if we're thinking from the top down, where we really should be starting is with models of our application code. There's lots of different tools out there that you can use to create models. And those models can be used to either generate code if you want to later on, or they can be used as, the guide, the roadmap, the architecture for handing it over to the developers to actually implement in code and hand code it, right? Multiple ways you can do that. But model-based design is really, I think, a great way, a great technique that all developers and teams should be leveraging. Even low-level, people working in super resource-constrained devices, you can still develop a model of how your system is supposed to work. There's lots of advantages to this. First of all, if I have a model, I can go to my customers and make sure that the model and the end goal actually meets what they need to do, right? So that's a really big benefit. Second, it decouples me from the low-level hardware, okay? And so that means that if I need to pivot in the future to different microcontrollers or upgrade to, running on a Linux-based machine, I have that flexibility available to me, okay? And so with that in mind, then, I can also, other benefits I can leverage, code generation. Maybe I can leverage AI tools. It really opens up the door to be able to use a lot of modern development techniques that really haven't otherwise been available to us as embedded software developers, because we've always so tightly coupled ourselves to the hardware. That's just always made it a struggle. Okay. And so model-based design, I think, is an area that is fantastic for us really to adopt and look into, as we start the new year. The other technique that I think you should be thinking about is containerizing and virtualizing your software development processes and development in general. Okay. Now, what I mean by that, leveraging tools like Docker, you can take your entire development process, all your tools, your libraries, all of that stuff. You can put it in a container, or you can virtualize it on a virtual machine. And what that does is it removes all of the issues of having different development environments. If you have, there's some companies I work with that have 200 members on their embedded software teams. There's a huge development team, right? Across different groups and things like that, but they've got, 200 developers. Could you imagine trying to get all of them individually installing their own tools and things like that? You end up with a library that's off a version, and suddenly it could break all of the software. Using a container, you can just distribute the container as part of your Git repo. They pull it down. Maybe they just pull down the image. If not, then they could pull down the Docker file, build it locally, and then they have the exact same tools that everybody else is working with. Most teams are much smaller than that. Maybe just less than a dozen people or so. But I mean, think about this. If you're working for a company that's trying to grow, that's trying to scale, you might not have 200 people today, but you might 3 years from now, right? Or 4, or whatever it happens to be. And so thinking ahead, thinking a little bit early of, hey, I need to containerize my build processes. That's a really good step to making sure that you can save a lot of time in the future. One person can go in and make adjustments to the development environment for everybody. And again, this is not removing that developer-centric trend. This is just making sure that our normal build tools and things like that are set and ready to go. Okay. And then, kind of going on off of that, if you containerize your builds and how you test your software and all that kind of stuff, that easily can be pulled into you developing and improving your CI/CD processes as well. Okay. So containerization, virtualization is really important when it comes to that perspective. It can also be quite interesting on some of the larger 32-bit parts, where you can actually use containers as part of your software architecture. Okay, not just to kind of collect your build environments and have a nice common development process. You can actually architect your software to use things like microservices or container-based development, and that can help you deploy software into the field more efficiently. Microservice architectures are quite interesting. I'm not going to go into detail today about them. That's something we'll cover in a later episode. But it adds a lot of flexibility to the development cycle for you if you are containerizing your build and potentially even your architecture. Again, depending on where you're at and what type of systems you're developing. Okay. So again, quite an exciting area. And we will definitely talk about that more in the future. Okay. And then the final technique I do want to leave you guys with, and I've actually mentioned this multiple times throughout today, but I think some of it leads up to this again, is adopting DevOps and CI/CD. CI/CD is a great technique and tool for you to use to automate your development cycle. It can alleviate some of your time and effort. It can help you improve the reliability of your software, deliver faster, and be a little bit more efficient. Okay, and so I have found that leveraging CI/CD is a great tool for you. CI/CD is much, DevOps is much more than CI/CD. DevOps itself can help improve the collaboration between you and your development team, IT, and your quality assurance folks. And so there's a lot there just culturally that can be put in place to help you have better communication across different teams in your organization. And so, DevOps and CI/CD, this is great low-hanging fruit for a lot of embedded software teams. Okay. And so if you haven't gone down this path very far yet, I highly recommend this year you bite the bullet and investigate it. Okay. Because yes, it will take a little bit of time to learn it and get up to speed, but you will find that once you do it, you are going to reap so many benefits. It's just fantastic. Okay. So it's really a great tool for you to leverage there. And so with that in mind, these are what I see to be some of the bigger general trends in the embedded software industry. There's a lot of underlying ones. You could look at your individual industries. If you're in defense, automotive, medical devices, if you're in space systems, and so on and so forth. Each of these industries has its own micro trends, as you might call them, within the industry. But today we've talked about what some of those trends are and some of the practices that maybe you should be thinking about adopting this year. That is kind of general across all of these. Okay. And again, we're looking mostly at 32-bit Cortex-M type microcontrollers. There's a lot going on, a lot of cool things coming up. And I hope that you'll join me in the future on the Embedded Frontier podcast to talk about some of these other trends as we dive deeper and deeper into some of these. Coming up next, we actually have some great episodes where I've interviewed some of my colleagues, and we talk about some of these trends and some of the things that are coming out that are happening in the industry that will hopefully give you some new insights to be able to help you be successful as embedded software developers, teams, managers, and companies. And so stay tuned in the future for some additional conversations about some of these trends. I think it's going to be an interesting year. Happy New Year. I look forward to talking to you in the future. And if you do find that you need any assistance with any of these types of topics or have feedback or interesting topics you'd like to hear talked about, please feel free to email me at jacob@beningo.com. That's jacob@beningo.com. And I will look forward to talking with you again in the near future. So thanks. And again, Happy New Year.